Namaste. Welcome to my channel. Let's get started. Now, before studying the divisibility rules of 7, 13, 17 or 19, we must know the concept of oscullators. What is an osculator? The osculator may be positive or negative. Now, firstly we will understand positive osculator. So, when on adding 1 to a number, it becomes a multiple of 10, then the factor of the resultant multiple will be the positive osculator of the original number. Okay. Now, let's understand it by taking an example. Let's take an example, say 39. Okay. So, on the process of finding positive osculator, what we must do that firstly we must add 1 to the number to get a multiple of 10. And as the number is 39, we can say that by adding 1 to 39, we will get 40, which is definitely a multiple of 10, right? Now, secondly, we must identify the number which is a factor of this resultant multiple but not 10. That means we can write this number 40 as 4 into 10, right? So we must find a factor of 40 other than 10. Okay? Or we can say that the number by which if we multiply 10, then we again get the resultant multiple. As the factor may also be 2, right? 2 is also a factor of 40. But 2 will not work here. We must get the number by which if we multiply 10, then we will again get the resultant multiple which we got by adding 1 to the original number. So here, if we multiply 4 into 10, then we will get the resultant multiple we got by adding 1 to 39, right? So, this number 4 now will be called the positive osculator of 39. Okay? I hope you understood this. Now, let's understand this by taking another example. Let's take 19 as an example. So, if we add 1 to 19, then we will get 20, which is of course a multiple of 10, right? Also, we can write 20 as 2 into 10. So, this 2 will be the positive osculator of 19. Now, what is a negative osculator? So, when on subtracting 1 from a number, it becomes a multiple of 10. Then the factor, obviously other than 10, of the resultant multiple will be the negative osculator of the original number. Now, let's check it by taking an example. Let's find the osculator of 31. Okay. So, what we will first do is we will see that by subtracting 1 from 31, we will get a multiple of 10. 10 3 is 30, right? Now, we will have to find a factor of 30 with which we will multiply 10 and the result will again become 30 itself. So, if we take 3, then after multiplying 10 with 3, we will get 30 as the result, right? So, this particular number here 3 will be said as the negative osculator of 31. Okay. Now, let's understand this by taking another example, say 41. Now, if we subtract 1 from 41, then our result will be 40, right? And we all know 40 is a multiple of 10. Now again, we can write 40 as 4 into right? So, other than 10, whatever remains in the factorization of the resultant multiple will be our osculator, or we can say that in this case negative osculator. Okay. Here we could also write this as, if we factorize 40, then we can write 2 into 2 into 2 into 5. And then again we could write 2 into 2 into 10. So we must remember that since this is a multiple of 10, then we have to exclude 10 from the factorization of the multiple we got by subtracting 1 from the original number, and then whatever remains here, 2 into 2 equals 4, will be our negative osculator of the original number. Now let's see what will be the negative osculator of 71. So on subtracting 1 from 71, we will get 70, right? And 70 equals 7 into 10. So this number here, the factor of 70 other than 10, which is here 7, will be the negative osculator of 71. I hope you understood negative and positive oscillators. Now we can define oscillator as when on adding 1 or subtracting 1 from a number we get a multiple of 10, then the factor other than 10 of this resultant multiple will be the osculator of the original number. If we get the multiple of 10 by adding 1 to the number, the osculator will be said as positive osculator, and if we get the multiple of 10 by subtracting 1 to the number, the osculator will be said as negative osculator. For example, let's take two numbers, 31 and 39. Now, on subtracting 1 from 31, we will get a multiple of 10, but on adding 1 to 39, we will get a multiple of 10, right? Our main motive here is to get a multiple of 10, and that too by adding or subtracting 1 and none other number. We must get a multiple of 10 by adding or subtracting only 1, okay? So here it was 31, we subtracted 1 and got a multiple of 10 which was 30, and here we added 1 and got a multiple of 10 which was 40. So in this case we can say that we will have a negative oscillator as we got the multiple of 10 by subtracting 1, and in this case we will get a positive oscillator as we got a multiple of 10 by adding 1. Okay, here 30 equals 3 into 10. So 3 is our negative oscillator of 31. And we have 40 as 4 into 10. So 4 is the positive oscillator of 31. So in other words, we could say that the numbers ending with 1 will have negative oscillators as we will subtract 1 from them to get a multiple of 10, and the numbers ending with 9 will have positive oscillators as we will get a multiple of 10 by adding 1 to them. But what about the numbers which don't end with either 1 or 9? For example, 7. We can't add 1 to get a multiple of 10, neither we can subtract 1 from 7 to get a multiple of 10, right? So, with these numbers in which we can neither add 1 or subtract 1 to get a multiple of 10, we will find the smallest multiple of these numbers in which we can either add or subtract 1 to get a multiple of 10. So, in case of 7, we know 7 2s are 14, 7 3s are 21, and by subtracting 1 from 21, we will get a multiple of 10, right? So, here we will take the third multiple of 7 and then find out the osculator of 7. So, first process is that we find for numbers which don't end in 9 or 1, that is for numbers in which by adding 1 or by subtracting 1 we can't get a multiple of 10, we have to follow the following rules. Firstly, we must find its smallest multiple which either ends in or ends with 9 or 1. Okay. For example, in case of 7, we know that 7's smallest multiple which ends in either 9 or 1 will be 21. Okay, required 7's smallest multiple we could say. As we also have 7 7s are 49 and 49 does end in with 9, but 49 isn't the smallest multiple. So we have to consider 21 as it is smaller than 49 and we don't have any more smaller multiple which ends with either 1 or 9. Okay. Now we will subtract 1 from 21 and get a multiple of 10. Okay. So the next process will be subtract or add 1 to the resultant or to the found multiple of the number. Okay, so we got the required 7's smallest multiple as 21 and now we subtracted 1 from 21 and got a multiple of 10 which was 20. And now at last we repeat the original process of finding oscullators. Okay, so what we did first, for finding the osculator of 7, firstly we found the smallest multiple of 7 which either ends with 1 or 9 and we got that multiple as 21. Secondly, we will find whether on subtracting or adding 1 we will get a multiple of 10. So we found that on subtracting 1 from this smallest found multiple we will get a multiple of 10. Okay, and then at last we will repeat the original process of finding oscullators. So according to that process we can write 20 as 2 into 10, right? And then the factor other than 10 will be said as the osculator. So we will have 2 as the osculator of both 21 and 7. Okay. and since we got the oscillator, or we can say that we got the multiple of 10 by subtracting 1, so it will be better to say that 2 is the negative oscillator of 7. Okay. If you want, you can take a screenshot. Now again, let's take another example. Say if we take 13, then we know that 13 also we can't subtract 1 or add 1 to 13 to get a multiple of 10, right? But we can find the smallest multiple of 13 which might end in 9 or 1, and then we can find further the multiple of 10. Now we all know that 13 threes are 39, right? 13 into 3 equals 39. So 39 is the smallest multiple of 13 which ends in either 9 or 1. Okay. Now next we will do is 39 plus 1 equals 40, which is a multiple of 10, right? Also we know that 4 into 10 equals 40. Now this 4 will be the oscillator of both 39 and 13, or as we have added 1 to get the multiple of 10, we will better say that this 4 is the positive oscillator of 13. Okay. Similarly, if we have to find the oscillator of 17, we will have to find the smallest multiple of 17 which ends in either 1 or 9, and that smallest multiple would be 51, which is 17 into 3 equals 51. Okay. Now 51 minus 1 equals 50, and 50 equals 5 into 10. So this 5 will be the negative oscillator of both 51 and 17. Okay. Also in case of 19, since this ends in 9 itself, we don't have to find the smallest multiple. We just have to add 1 and we will get a multiple of 10, which is 20, and 20 equals 2 into 10, and since we got the multiple of 10 by adding 1, so 2 is the positive oscillator of 19. Okay. I hope you understood this whole theory. It might get a bit confusing for some of you, but I assure you that if you study this patiently, then you will surely get the knack of it. It is not that tough and a very interesting theory. I hope this class was useful for you. Please like my video, share with your friends and family, and if you haven't subscribed yet, do subscribe my channel. Also, if you have any queries relating to this theory or any other theory of mathematics, do ask me through the comment box below or through my email ID crackmathematics with Deepshikha. I will surely try to help you out. Thank you.